I'm also an ex-Google software engineer.
Yeah, you really had to mention that ex-Google engineer, right?
Oh, you have to. You have to. It's like a rule.
So hey everyone, this is me Rachit and welcome to yet another video. Today we have with us a very special friend of mine. He goes by the name Clement. I am really very sorry if I mispronounced it yet again. Today what we are going to do is a mock interview. Clement will be asking me questions and we will basically create a real interview scenario wherein I am giving the interview and I will try to do a data structure algorithm problem, and let's see how this goes. I know that most of you might be knowing Clement already from his algo expert work, but anyways, for new viewers, can you just introduce yourself to them, please?
Sure, no problem. So first of all, thanks for having me here. This is going to be fun, hopefully. And yes, my name is Clement Mihalescu. I'm the co-founder of Algo Expert, which is a website that helps people prepare for coding interviews, algorithm interviews. By the way, if you want to check it out, algoexpert.io/Rachit, and you can get a discount if you use the promo code Rachit. I'm also an ex-Google software engineer, and I just really like coding interviews, so we're going to put Rachit to the test today.
Yeah, you really had to mention that ex-Google engineer, right?
Oh, you have to. You have to. It's like a rule once you leave the company that you have to always introduce yourself like that.
Sure, then I'll be giving the interview as an ex-Microsoft engineer then.
Exactly. Perfect. All right. So, are you ready, Rachit?
Yeah, sure.
Okay, so the rules are going to be simple. We're basically going to be imitating what a normal coding interview or phone interview would look like, because we're going to be doing it over Google Hangouts and over Google Docs. But so we're going to give you roughly 45 minutes. This is a question that you've never seen before. We haven't talked about this before, so it'll be sort of like the real deal. And that's that. Sound good?
Yeah, sure. Can you share the doc link?
Yes, I'm sharing the doc link right now. All right, so let's get started. I'm going to put a timer for 45 minutes, and that's that.
Awesome.
Cool. So, okay, Rachit, so have you ever heard of this thing called the infinite monkey theorem?
Of course not.
Okay, so it sounds very weird, right? Infinite monkey theorem. Basically, the thing goes like this. In theory, if you were to put a monkey in front of a keyboard and have the monkey type random letters on the keyboard, after some huge amount of time, that monkey would be able to write basically every word in the English dictionary, every word in any dictionary. The monkey would be able to type like anything out, just because of the laws of sort of probability and statistics and randomness. Does that sort of make sense?
Yeah, okay.
So now I wanted to introduce that sort of just as a funny intro, but if you take the number pi, right, you know, the number pi 3.14 blah blah blah, that number is sort of similar to the monkey in the sense that it's a number that never ends. It's there are an infinite amount of digits in the number pi, and the numbers or the digits are random. And in theory, there are people who say that in theory you could find every word in the English language or every sort of combination of numbers in the number pi, or somewhere in the digits of pi. So now what we're going to do for this algorithm question is I'm going to give you the first n digits of pi, okay? So basically it'll be like a string of the numbers of pi, and there are going to be roughly n numbers of pi, or digits of pi. And then I'm going to give you a list of numbers that are sort of like my favorite numbers. And I'm going to want you to basically tell me what the minimum number of spaces you would have to put in the digits of pi, such that all the resulting numbers would be found in my favorite list of numbers. And so I'm going to give you a sample input and output just so that you can sort of understand what I mean. Imagine I give you this string. This is a string, what I'm highlighting here. These are like the first, 30 digits of pi or something. And then I give you a list of these numbers. You see, these are all, again, strings. And you would have to basically find all the places where you would have to add spaces in the digits. So maybe you could add a space here. Maybe you could add a space here. You could add one here, right? And you want to find all the resulting numbers. You want them to be in this list of like what I'm going to call my favorite numbers. And so here the sample output would be 3, because if you add just 3 spaces, right, 1 here, 1 here, and 1 here, you have these 4 numbers that happen to be found in my list of favorite numbers. Does that make sense?
How does 793 is occurring over here?
793 is not necessarily occurring, but the idea is that if you add 3 spaces in these exact areas here, the resulting numbers, 314 is in our list of favorite numbers.
Got it.
This big number is here. Okay.
Yeah, that clarifies it. Yeah. Okay, so basically I have to split my pi string, which is of n characters, into some number into some other numbers, so that all of them occur in that array, your favorite array.
Yes.
Awesome. Cool.
And you want to minimize the number of spaces.
Yeah, got it. Okay, so I think it's quite straightforward that we have to start with the initial character, which is 3 in this case, and we go as long as possible, and we find the longest substring or the longest prefix. For like in the given case 31415, we will go on and on until we reach a point post which we cannot ever form the string which exists in the array. So what I'm trying to do is basically find the longest prefix which exists in your array.
Okay.
Once I get that, I will enter a space over there. Basically that's my first split, and then I will do the same thing for the rest of the string.
So here for this, you would say basically you start at the beginning, you see that you arrive at like 314, you see that this is in the prefix, or this is in our favorites, but once you get to 3141, this is not in the things, so you stop?
No, basically I will go as long as possible, because it might be the case that you do have a 314159265 in your favorite list. So
right.
This is possible that this much part is there in your array. So I really don't know that when I match the first 314, it's the longest or not. I will need to check whether I can go much bigger than that or not.
I see.
Right. So basically, once I go in the longest direction, I will pick that and then do the same for the rest of the string.
And so
this is a greedy approach.
Go on. Yep.
And it's prone to fail. Like for example, this might happen that there is actually 314159265 and then there is also 314, as you can see. But if we pick the longest prefix initially, then it might happen that in the rest of the string, when we are trying to do the same, it might happen that we actually end up not even, basically we make it impossible to solve the problem. So going greedy does result in minimization, but it comes at a cost, and that cost is wrong answer.
Right.
Does that make sense? Like,
yep.
Because it might happen that we pick the longest one, but we should not have actually, because the first shorter partial match was resulting in a possible solution, but since we picked the longer one because we were going greedy, we actually failed it.
Definitely. Yep. That was I was going to give you the example of what if, this huge number was in the thing, but the number 9 wasn't, but that's exactly what you said. So
of course we need to ensure that for the rest of the string we can also do this. Okay. So what I'm going to think is, basically, let's say we have a function check which takes care of some index, let's say pos, and what it does is it basically checks if it's possible to I would say disintegrate the string for the suffix which is starting from position pos. So let's say the length of your string given s, so basically given is s, is equal to nothing but this long thing, and then let's say the length of that is n, right? So you can say mod s is n. So now what I'm saying is check pos returns whether we can solve this problem for s pos n.
Yeah.
And instead of just checking, it actually also returns the minimum steps or the minimum spaces you need to insert. Let's have a function for that as for now, right?
Sure.
And if this returns -1, it means that it's not possible. Okay.
Yep.
So essentially what our answer is nothing but check 0 if we are using 0 based indexing. Right.
Because when you do check 0, it's from the position 0 all the way to the last index n, right?
Yeah. It's
Yes.
actually n-1, but basically the last position is not included.
Sure.
So now what I'm trying to do is see how I can reuse the check function to solve the problem for check 0. Right. So basically when you are at check pause, right, you really do not care about all the characters which were before pause. We are interested in the suffix, right? Suffix s pause till n. So what I can do is to solve this, I'm just going to just give me a sec. Yeah. So what I'm going to do is iterate on every prefix from starting from pause that exists in our favorite array. Alright.
Yep.
And then let's say right now we are at the prefix let's say s pause till j, right? So let's say this exists in your array, favorite array. So if that happens, what we can do is basically we have the choice to make a space over here. So we do one space, which is one space, and then for the remaining we simply call check j plus 1, right?
Right.
And we just need to ensure that check j plus 1 does not return -1. So this should never be equal to 0, right?
Yep.
And if we maintain the overall minimum, we can basically then assign that to check of pause. Hello?
Yep. Yeah, I'm following.
Yeah, so I think this should work.
And so, are you thinking of like would you start when you first call this check function? Would you start basically with check of 0, or would you start with the very end, like check of n-1?
I'm not sure what exactly did you mean.
Like when you, I suppose maybe if you could you run me? I guess yeah. Well, could you run me through an example? Like if we take maybe a shorter version of this example, or even that example, you can run the first couple of calls.
Yeah, okay. So let's say we are having this thing.
Sure.
And I will do that above only because we have everything written in one place.
Yeah, no problem.
So let's say we have this, and I call check 0 right now.
Yep.
So what's going to happen is I iterate on every prefix possible. So in this case, let's also modify the input array. Let's also add a 3.
Sure.
So I check that 3 exists in my favorite array. Then I would call check 1 for getting the answer for this remaining string that I need to take responsibility for, and it will return me maybe 2, 3, 4 or something like that, or -1 if it's not even possible to disintegrate the string into the components of favorite array. So that's one case. The other case is 314, and then I will call my check function again for this part of the string.
Yep.
And this will, in this case, ideally should return 2. And since we had added one break for 314, the total becomes 3. And since we are taking overall minimum for all the possibilities, we can basically evaluate that 3 is the minimum answer for this case.
Gotcha. I see. Okay. Let's see if we can code something up then.
Sure. So what I'm going to do over here is just first I'm using the C++ language, and I'll be using a function. Let's say I really take some time in coming up with some really good names. So instead what I'm going to do is use some dummy names, and later on if we have time we can modify and increase the code quality for the code.
Sure, sounds good.
Cool. Just give me a sec. Alright. Let's say int minimum spaces, and let's say we are having the string s. So and then we also have a vector, right? Favorite array. Alright, and let's call this pi.
Sure.
So I'm having pi, I'm having my favorite array, and then what I need to do is basically do something like cout check 0. I can have a global variable. Or shall I? Okay. So right now I'm basically doing a move to the global variable so that my function looks a bit simpler. Otherwise we can pass in as arguments also. So basically this check function would need access to this pi and favorite.
Right. Hey, well, you can use the global variables for now if you want.
Yeah, sure, thanks. So basically let's say they are right over here in the global namespace. Alright. I think now let's say we already have them initialized with the values that we wanted, right? So this check function can do something like this. If pos is basically n, you can simply return 0, handling the base case. And then otherwise what we can do is for in j equals pos j is less than n, and then j plus plus, we can do something like cool, string cur is empty right now. We can do, so I'm building the prefix.
Yeah. Cur is the prefix.
Right. So I'm basically iterating on all the prefixes possible, and if exists in your favorite array this number, so we'll come to this part later. Basically over here what we can do is for string s in your favorite array, we can do something like exists s is 1.
Sure, and exists is like a hash table or something, or a map or something.
Yeah.
Okay.
Yeah. So that's basically an unordered map just to get that order 1 lookup and putting the key into the map.
Sure.
So we can have a string do bool exists. Yeah. So now if exists, then we have one possibility. So if exists, we can do something like int other is basically checking for the rest, which is j plus 1, and if other is basically not equal to -1, so it means it was indeed possible to disintegrate the remaining of the string. What we can do is something like answer is minimum of answer comma 1 plus other, because that's how it has to work. And then
So wait, just 1 second.
What you can do-
just to make sure that I'm following. So if other, if whatever the check of the suffix at this point after j, after the prefix, I guess, is not -1, then the current answer is going to be the minimum of whatever the current answer is, or one more space plus other. Sure. Yeah.
yeah. Cool. And I think the other thing is to basically return the answer over here. So this code should work. There are few things that we can do with it. Of course, this is a recursive solution and the time complexity looks bad. So to handle that, what we can do is use dynamic programming over here. And to do that, what we can do is store a reference to something like dp pos, right? And then if we have visited this position already, then we can simply return the answer. Otherwise we can say answer is int underscore max, and yeah. So now the time complexity has like really increased a lot, because we are not doing the same work again and again.
Right.
And what this dp and visited are, let me just create that as well. So we can say pos is something like this, and then dp is also, sorry, this is dp, and then we have visited like this, where n is like the max length of the string s that we can get in the file.
Sure. And so basically, so you're essentially like caching all your answers, is what you're saying.
Yeah.
And sorry, could you repeat what you said viz n is?
So since it's a global array, it will be initially 0.
Okay.
And one thing that I have missed over here is just to make that, yeah, this has been listed. So what I do is I'm storing a reference in this variable ans answer for the current dp state, and if I've already visited this dp state, I am pretty much sure that I can simply return answer.
Gotcha.
And if not, then we are basically doing this part over here, and then I'm also marking that we have visited this state, so next time don't do that rework.
I see. And the answer, okay, I see. But do you need the duplicate dp and viz? Like, aren't they basically the same thing?
Yeah, of course we can get rid of them. Basically we can initialize the dp with something like -1,
Right.
and instead of checking visited pos or something like that, we can check that if actually not -1, because that's one of the values which we are returning, right?
Right. But you could do some other value, and maybe this would make more sense
exactly.
in another language.
So if answer is basically let's say we have answer is something like uninitialized or undefined, we return the answer, and undefined is something like a constant undefined. We can basically use a -2 or something in our case.
Right. Okay, so
one thing, so just let me go through this once.
Okay, sure. With the example?
Because I need to take care of some things, like we have to return -1, which we are not doing right now.
Sure.
Alright, so it might happen that this if condition is actually not met, and in that case what we can do is that over here, so basically we can check if answer is still int max, we can return -1, otherwise we can return answer.
Yep.
Hello?
Yep. Yeah.
Cool. Yeah, this seems to work.
Okay, so Rachit, this is, I think we have actually exhausted the infinite monkey pi theorem, whatever you want to call it. So I actually want to move on to something else.